Assalamu alaikum guys, welcome to this tutorial. Today you will be learning DAX beginner to advanced in just 3 hours and with one end-to-end projects after this tutorial. And this video contains timestamps. So if you want to watch your desired part, you can just move to that part. So without delaying, let's begin. So in the first step, let's have a look at the data we are working with. Now you can see that we have 5 tables. We have this sales table, which will be our main table we are working with. It's our effect table. So all the information we have about all the transactions, all the sales, these are all included in this table. So here we have each transaction together with additional information. For example, which customer, which location it was sold, which product it was, and this ID are referring to our other dimension tables. So in these dimension tables, this will be these 4 tables. We will have additional information. For example, the product ID number one, it's referring to our product ID in our products table. So now we know that this is the product potato chips. It has this price, this profit margin, and this text, right? In addition to that, we have also the customer table where we have the customers and the employees as well as the location table. You might be now thinking that this is not very complicated data, but you will be surprised what we can achieve with powerful DAX. So with measures and calculated columns, we can gather a lot of information and analyze very deeply into this data. So what we will be doing now is we will connect this data to Power BI and we will create our data model. So now let's jump back to Power BI. So now we are in Power BI and we want to get data. So we select Excel as our data source. We navigate to our file. We select our file and then we load it into the model. Here we can select all our 3 tables. We can look at them to check if everything is correct, and then if everything is correct and looks good, we can click on load data. Once our data is loaded into Power BI, we can go to our data model, and here we can see that Power BI has already auto detected the relationships. So which columns have been connected together? As in this case, we see this might not be always be correct. What Power BI is doing here, just looking at the column names, and if 2 tables have the exact same column name, Power BI will connect these columns together. So in this case, as we see in the location table, this is not exactly correct. So in this case, we want to edit this relationship. Therefore, we make a double click on this relationship. And now in the sales table, the ID is not the column we want to use here for this relationship. Instead, we want to use the location ID because that's the ID that is referring to our location table. Therefore, we select location ID and click OK. Now we can see that the relationship is now correct. So now at the relationships setup. Okay. Now let's have a look at how we can create our measures and our calculated columns and what is actually the difference between those. Let's move to our data section. This is the section where we have a great overview of all our data. This is a great place when we are working with calculated columns and measures because we have a nice overview of all our data. So let's start with calculated columns. What are calculated columns? A calculated column is basically just logic, like a formula that is producing a new physical column in our table. That means For each row, we have a new physical data point. So basically, there's not a big difference to the rest of our columns because we just have a new column that is calculated after some logic, like some formula we have provided. So let's look at one first example how we can create a new column. The way I like to create it is I do a right click on the table I want to place the new calculated column. So I do a right click on cells and select new column. And the same I can also do in our report section. Here I also have our fields which are our columns, and I can also make a right click on the cells, and I can also select new measures as well as new column. Another option we can do is we can select our table and then we can click on here new column or new measure. This will also place the new calculated column, respectively our new measure, into our selected table. Let's do that, but move back to our data section. So now we want to move a new column into our sales table. So therefore we select the sales table and we click on the new column. This will open our formula tab where we can place our formula. That means our logic for our new calculated column. First of all, we can give a name. So for example, let's call that price. And now we can provide the formula by which the calculated column is calculated. In this case, we just want to use a related function. And in this related function, we can use, for example, the price. And what you see now already is said, we can just type anything and we can use auto completion of Power BI. So it automatically detects which columns do exist, and it is also checking the syntax of our formulas. So now we have already the suggestion that we can use the price column in the product table. That is what we want to do. So we double click on it, and now what this function is doing, this related function, is that it is pulling the price of the products table into our sales table. Now you remember that we have the product ID and we have these two tables, that is the sales tables and the product tables, connected in our model via the product ID. So Power BI actually knows product ID number 66, and you can look in the product table and he can find the price there, and by this relationship we can actually pull the price into this sales table. Now we can also put here in our format tab that we want to use two decimal places, and now we can see that this is the price that is coming from our product table. Now I am not saying that this is a very smart thing to do, because we actually already have this information in our data model, but this is just to show how the calculated columns basically work. So now let's look at another example of a calculated column. Now we want to calculate the revenue that is calculated by the quantity times the price. So for that, again we select our sales table, and now we can click here on your new column, and you can just right click and select your new column. Now first, of course, we give a name, that is revenue, and now we can add our logic to it. That is, of course, we want to multiply the quantity, and now we again see the auto completion of Power BI, which is very smart. So we can just select here the sales quantity and we can multiply that with the price. So the price, which is the column we have just created before. So we can multiply these two, and what Power BI is doing is just calculating the result of it. So of course we can also now add here two more decimal places, and if we select here, for example, something that is not 1 in the quantity, we see that now the revenue is calculated by multiplying the quantity with the price. So what we can see is that we have now calculated two columns that are physically existing in our table. So for each row we have a new calculated values here, and that is the main difference between calculated columns and measures. So now let's have a look what are measures and how do measures work. So the main difference between a calculated columns and a measure is that a measure is not physically existing in our data table. That means it's only virtually existing, and it's only calculated when it is needed. That means when we visualize this measure in one of our visualizations, so that means that we only have to put the potential to calculate these columns, and they are not always calculated all the time, and that can bring a benefit in performance. Therefore, in case of doubt, it's preferable to use measures over calculated columns if it's possible. So now let's just first, to understand the concept a bit better, look at one first example of a measure. So we move back to our report view, and we want to first have a look at our revenue. So we can see that this is our calculated column, and we can actually also change the format by selecting here these fields, and by selecting here this dollar sign. So now we see that we have here the format in dollars, and now we can easily use other columns like the location ID to visualize our data. Later we will see that we can also calculate the revenue with a measure. But first, let's look at a very easy and simple example of a measure. So to create a measure, we also make a right click on our sales table where we want to put our measure, and we click here on new measure. Now the same thing happens like when we created a calculated column. We see our formula bar, and here we can, for example, write a name. Let's say we write the name of total, and then we can provide the formula similar to when we created a calculated column. So in this case we just want to make a very simple calculation, that is the sum of let's say the quantity. So we type quantity, and we see already here the suggestion. That's what we want to use. So it is the table name, and then in these brackets here after the column name, and we always see here also the description of the function we are using, as well as the syntax that we have to stick to. And if there's some mistake, we also see this the red underline thing, so we know that something is not correct. For example, in this case we don't need this bracket here in the beginning. Okay, so this should be now correct. We can now close the parenthesis, and we can calculate our measure. So now we can see the measure is existing, and it is placed in our sales table. We can also see that this has a different symbol than our calculated column, so we can immediately see what is a calculated column and what is a measure. And now we can easily also drag this in our place, and we see that now as we visualize it, it is being calculated. But now only this has been calculated, and if we go to our data and we move to our sales table, we don't see this column for the total that we've just created. So that means it's not physically existing, but it's only virtually calculated when we are visualizing it. And there's a bonus for the performance. So when we have huge tables we were working with and we have a lot of calculated column that can take up some space in our memory of our PC. So therefore it's better to use a measure over a calculated column if it's possible. So to show that we can often use a measure instead of a calculated column, we want to also calculate now the exact same revenue with a measure instead of a calculated column. So let's make a right click again on the sales table, and now you select new measure, and this will be now our revenue measure. So let's type revenue measure equals, and now we want to use two functions. The first function is an iterative sum function. That means I will explain what that means. We'll use the sum function, but it will return the sum of an expression evaluated for each row in a table. So what does that mean? I'll explain that in just a second. First, we were just finished of this formula. So the first thing this formula expects is a table that has been used in our case. It will be the sales table. After that, we need the expression that has to be summed up. So in our case, it will be the price multiplied with the quantity. So now what this SUMX function is doing is, in the first step, it's always for each row in our sales table calculating this multiply. So the price multiplied with the quantity, and after that it is calculated for each row. We sum these results up. So we were finished this formula, so now we can have our measure also and visualized, and we can bring that a bit bigger, move that a little bit up, and now we can also use the location ID to see that the result is actually the same. So the main thing to remember from this lecture is that the difference between a measure and a calculated column is that the calculated column physically exists in our table, whereas our measure is not existing physically in our table, but it's only calculated when it is needed. So before we add the aggregation functions, we will look at a quick tip we can always use in the beginning of a new project. And with the tip, we can automatically create a date table that contains all the dates of our model, and that can be very useful. So there are two options to do that. The first option would be a little bit more manual, and that would be with the calendar function. We'll have a look at this function afterwards. But first, we'll look at the other options, that is to create that date table automatically. So what is this calendar auto function doing exactly? This function returns a table with only one column, and that column is called date. And this column contains a contiguous set of dates. That means there are no missing dates. So we have a range of dates that are automatically treated based on the data or model. What does that mean? So basically what Power BI will be doing is it will look at all of our data and it will find the earliest date in our model, and it will also find the latest date in our model, so it can calculate the full range of dates that are in between the earliest and the latest dates. It can also be possible that the earliest date is in one column and the latest date is in another column, so that's totally possible.
Now there's just one thing we have to keep in mind, and that has to do with here this fiscal year and month. So what does that mean? That means that the date range will always create all the dates between the beginning of the fiscal uh, and up to the end of the fiscal year associated with our latest date. So if the earliest date is 2nd of February 2017, we'll have a date range that starts from 1st of January 2017 because that's the beginning of the fiscal year. So we can set optional the parameter of the month where we want to have fiscal year to be started. So if we don't use this parameter at all, it will be by default the number 12. That means that the end of the fiscal year will be the December. So that's what intuitively is usually the case. And then would have all dates in between 1st of January and December 31st. If we use a parameter here, for example 3, which represents March, all the dates between March 1st, which will be the beginning, and February 28, which will be the end of the fiscal year, will be returned. Now, let's not make it too complicated and have a look at a real example in Power BI. So let's jump to Power BI to have a look. Now, we want to use this calendar auto function. To do that, what we'll be doing is just select one of our tables. It doesn't matter which one, because anyways we'll not create a new column, but we'll create with the DAX expression whole new table. That is what we'll be doing. Therefore, we click on new table, and then also this bar will open where we can specify a name of our new table. So we can just call this date table. And now we will just be using calendar all to a function, and we already have the auto suggest, and we don't need, as I said, this parameter physical year and month. We can just leave that blank. So let's have a look what the results of this table will be. As we see, we have now here a new table with only one column, and that is the date column. So let's have a look which dates Power BI have produced. So we'll just move that up a little bit and look at this with a table. So we click on that table here, and now what you see is that Power BI automatically shows this as a hierarchy. So because it is date format, automatically Power BI will use this date hierarchy with year, quarter, month, and day. I don't find that very comfortable right now. Therefore, I would change that from the date hierarchy to the normal dates. So now we see that we have all the dates starting from 1st of January 2017 until 31st of December 2020. Now, as I said, keep in mind that this doesn't mean that the earliest date in our date is 1st of January 2017. It can be also that, for example, the earliest date is 5th of January, but as the start of the fiscal year is 1st of January, or the dates until 1st of January will be created. So if we have a look at our original data, then we can compare these dates. Let's use now the original dates and also use a table so we can easily compare those. So now we see that the first date in our data is actually 1st of May. Anyways, in our calculator table, all the dates starting from the beginning of the year is calculated. So now let's have a look what is changing when you use here a parameter that is specifying the end of the fiscal year. So for example, we can have a look if we insert here the 3, that means the year will end at the 28th of February and start at the 1st of March. So now let's have a look what is changing when we use this state. So now we see the first date in our calculator table is January, is not January 1st anymore, but it's the 1st of April and the last year, and our model is now 31st of March 2021 because that will be the end of the year. So just keep in mind that we can have different table with different data columns, and Power BI will now, with this auto calendar function, look into all of these columns. So now after we have seen how to create a calendar with the auto calendar function, let's have a look at a slightly more manual method to create a dates table, and that is the calendar function. This function expects two inputs. The first one is start date, the second one is the end date. So, for example, that can be easily just manually a certain date and the year and the end year also certain date. So like that, the whole range between start date and the end date will be created in our dates table. Another option would be similar to the calendar auto function, that is that we can use the minimum of certain table until the end, so the maximum of, for example, another table. So that method is a little bit similar to the calendar auto function, except that we have a little bit more control over which table will be used for the first date and for the last date. And also we don't have the end of fiscal year as an input that we can specify. But I suggest let's have a look at how this works in reality. So let's jump to Power BI. So we have here our dates table that has been created with the calendar auto function. Now let's use just the calendar function. Let's have a look at what we have to insert here. First, we can enter a start date. So for example, we can use the date function, and here we can, for example, use the year 2018 separated always by a comma. Then we can insert the month. For example, it should be May, and then can insert a day. For example, the 1st May 2008. Same thing can also do for the end of the year. So again, we separate this by a comma, and let's use another date. For example, 2022, 2020 and May and 1st. So let's have a look at the result of our new table. So now if we saw this ascending, then see the first date is 1st of May and the last date is also 1st of May 2020. Now let's have a look at how we can use other tables to specify the start and the end of our date range. So let's again change this function here just a little bit. So for example, instead of this manually inserted fixed date, we can, for example, use our existing sales table to specify the beginning of our date range. So for that, we'll use the minimum x function, and we will insert here at the syntax. First, the table that we will be using, that is the sales table. So we just type sales, and then we just specify the column which is our date column. So we insert dates, and this should be our column. So let's have a look at how our date table now is changing. So now note that our first date is 1st of May 2017, like the earliest date in our original table, and the last date will be, of course, 2020, 1st of May. So now that gives you a little bit more control over your date table. And the cool thing about this function is that whenever your date is updated, so for example, you get new dates in your model, then also your calendar, so your date table will automatically updated according to your new data. So as we have now our very simple dates table, we would like to have a couple of more information about our date. So now let's have a look at a very cool trick With that, we can add a lot of interesting date features into our dates table. So now let's have a look at a very simple and easy way to automatically always in the beginning of a project, for example, create a table that contains the date range as well as a lot of additional date features that are interesting to us. So for that, we have this script that we always can copy and paste into our project. So let's copy that and paste it into our project. So what we will be doing is we are use this date table. So we'll just insert this script in our formula bar whenever we have clicked on a new table with a DAX expression. So first, quickly have a look at how this works. This table starts off with a starting table. So in our case, that is the calendar function. So this, as we remember, returns a table with a single column. And after that, we can add new columns. So first, we start with the name of the column, and after that, we specify what the column contains. Don't worry too much about what is happening here exactly, as we will be looking at this later. So for now, let's just create this table and have a look at the result of this table. So now let's navigate to our data view to see what this table is containing. So as we see, we have now a complete table with a lot of interesting information, such as the complete date. We have also the year, the month. We have combined the year and the month. We have also the month name. If we want to, uh, we have it also shorter version, and we have also weekdays and the quarters. So that can be a very helpful thing if we want to use this information. Then we just have to copy and paste one simple script to create our date. Just keep in mind that, of course, you want to change here the specified table in your project. So in our case, this is just our sales table, and here the column, which is the date column. So that's the only thing you have to change, but the rest of that you can always use in your project to create your dates table. So now you can easily use this script, which you can easily copy and paste from the next lecture. After after we have created our date table, it's good to navigate to our model view and to connect to our date table with our with the rest of our model. So for example, in this case, we should connect the column dates of the sales table with the date column of our data table. So we just connect this by dragging and dropping. So like that, we have created the connection of those, and this enables us to use our date table together with the other fields. So now after we have created our very nice state table, we want to start with a very basic and simple tax calculations. So because of that, we would start with the basic aggregation functions. But before we'll be doing that, we'll organize our measures a little bit, because right now we have here a couple of measures, and it can be that they are in different tables, which is not really nice sometimes to work with. So to have it a little bit more organized, we will create a key measure table, and in the table all our created measures are living in. So like that, it's easier to organize box to do that. To do that, we are navigate to home ribbon and we'll click on the enter data. So that means a new table is created and we can manually insert data. So we click on that, and actually we don't want to insert any data, we just want to create the table itself. So let's just call it key measures table. so we don't need to specify the column name because we are remove it later anyways. So let's just click on load and we'll see that now there will be a new table, and that is our key measure table. And now we want to move our creative measures in this key measure table, and later on also we'll be create all the measures within that key measure table. To move our measures, we just select the measure we want to move, and then here we find the name of the measure, and here also the home table of measure. So to move it, we just select a different home table. So for example, we just select our key measures table, and we see that the measures has been moved into our key measures table. And do the same thing with our total measure. We selected and then we change the home table to key measure table. After that has been moved as well, we can now remove column number 1, which we don't need. So we just right click and then click on delete. So now we have here our key measure table with only our measures. So that's a tip. I would always recommend to create a key measure table where all our measures are living in, because it can happen that we have between 10 and 15 measures we'll be creating. So like that, it's a lot easier if we can manage all of our measures in just one table. After we have done that, now we can have a look now at the basic but very important aggregation functions. So one of the most basic but also most important functions are the aggregation functions. So a measure always has to aggregate something. For example, it can sum up something, it can calculate the average of something, calculate the max, or do some other aggregation. So let's have a look at some of the aggregations we can do and how we are doing that. So first, let's clean that up a little bit by just removing here our tables, and this one we can also remove, and this one we also don't need. So now let's create our measure. We want to place that measure in our key measure table. Therefore, we select our key measure table and then just click on new measures. So now we can call this measure, let's say, average sales amount. Average sales amount, okay. And so we want to use now the average function. So we type in average and we can now select the function we want to use. So in this average function, now we have to put in a column. In our case, we want to calculate the sales amount. So the sales, we can also call it quantity. So to calculate the average of the quantity, so we just type quantity, and here we have already the suggestion which we can easily use. So now there's a very simple and basic aggregation function that is calculating the average. So now let's have a look what this function is doing. So if we want to visualize this measure, which has moved it here into our open field, and let's use a table for our visualization. So the average of our amount that has been ordered is 2.95. We can use this measure now together, for example, with our customer table. So we can insert here name as well, and now we see the average sales quantity per customer. We can do the same thing, for example, also from a location column. So we just move the average column into our visualization. uh, so now we have also the average, and we can remove here the revenue. So we see here now the distribution of the average sales quantity across our location ID. Another interesting thing that we can calculate would be the maximum of the sales quantity. So to do that, just again select our table, our measure table, and we click on a new measure to create a new measure. Now we just want to call that the maximum of sales quantity. And of course we use now the max function. In the max function, if we want to calculate the maximum of a column, the maximum value of a column, we can just simply paste in the column name, that is in our case the quantity. So we just select the quantity and then let's have a look what is this calculating. We just move that into our table and we see, for example, this customer has the maximum of the sales. uh, this customer has the maximum of the sales quantity, and uh, the others, for customers, the values are obviously different, and we also see the total. So the maximum of the sales quantity of a customer has done in one transaction is 15 products. So to understand a little bit better, let's move again to our data. Here can always understand things a little bit more easily. So let's have a look at our sales table. The sales table has all our data, and here for all the customers with a certain customer ID. So one customer ID represents one customer, and what our measure is doing is that is looking for each of the customers which one is the maximum quantity for a given customer. And the same thing, for example, if we want to use this measure with the location, so it's always depending on how and where we are using this measure. So if we are using it in the location together with the location, then the maximum is calculated not for the customer but for the location. That is just important to understand when we are using measures. So you see that it's pretty simple to work with aggregation function. Of course, later on we'll do a little bit more elaborate and complex things. So we already had a big of how to use a very basic version of the aggregation functions, such as the minimum, maximum, or the average. Same is for sum function, which is a very common function, very simple and easy to use function in this basic version. So we just type sum, then we can enter the column name. For example, we can count the quantity of sales. So we just use that, and now we can visualize the quantity of the sum in some of our visualizations. So for example, we just drag that in here, and we can now visualize that together, for example, with our products. So now we see which product has been sold how many times. That's not very complicated and it's very easy to use. But there are also some other versions of these aggregation functions. So in our case, we will go over this, the most important of these variations. So to each of the basic aggregation functions, there are some variations or some little bit specific versions to them. In the case of the count function, the count rows, the count blank, distinct count, and the count x, count ax. So to me, in the beginning, that was very easy. Even after I have read instructions to that functions, so that's why in the example of the count function, we'll go over the differences with an example of each. So if we have a look to some other functions, the sum function also have the SUMX function and the average function have also the average a function, the average x function, and so after we have understood the concept of those, we can also apply them the other aggregation functions. So I suggest let's start the basic versions of the count function and then see the difference with the other ones. So for that, I have created just a simple sample table. Let's have a look at this sample table so we know what we are talking. So we have here three columns. The first one I have just created, so you can do that yourself if you want by entering some data here, and then I have just put some new columns here. I put one here and I put one again and so on. So you can do the same if you want. Okay, and then we close that again because we have already created that table. But you can do that yourself too if you want. And have a look at what values are in this column. Then see here there is 1, 2, 3, text 1, text 2. Some of them are duplicates, and we also have this empty value. So there's nothing in there. But that's a little bit different to this column, even though it's not obvious in the first move. But if you click on here and see the empty fields are now real blanks. So technically there's a little bit difference, and it can happen that in your data you have blank as well. So that's why you look this case as well. So that you can do that yourself too. I can show you here how I have created this column. That's just a simple if statement. That means if column, our sample column has nothing there, then we want to put a blank. So that's why here and here we have a blank, because here and here there is nothing there. And in all the other cases, so if we look at the syntax of the if statement, we have always the condition. If that condition is true, we put this one. If the condition is false, so if there is nothing, there is not nothing in there, then just use the value of the row sample column. So if it's not empty, then use the one here, also the one here, also the two. So if you want, you can easily now replicate that. And now the last one, we have some logical value. So we can also demonstrate what happens if we use the counter. And to show you also this column, let's also have a look at sample column 2. There's also another simple if statement. So if in our sample column it's nothing in there, then just put false, and there is something in there. So if that condition is false, then just put true like in here. So now let's have a look what happens when we create a measure with the count function. Let's just move that a little bit down here. Go to our key measure table and then create a new measure. Let's call that sample measure, and we just used the basic versions of the count function, and we want to sum our sample column 1. So sample column 1, close the brackets, and now let's visualize that. See what the result is. Can occur here, so it's a little bit easier to see. And now we see the number is 7. If we have a look at our data though, then we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means our blank values have not been counted. So what this count function is doing, let's have a look at it again. Counts all the values in there, and if there are real blanks, that means that we can see. Let's have a look at our column. We use the column 1 if they are real blanks like that. These are not counted our count function. If we have on the other hand just something like that, let's have a look at our original column, and that is just look like a blank, but it's actually not a real blank, but just has nothing in there. This could be counted with the count function. So if we remove the 1 and we calculate just the normal sample column, then we have here now a 9 instead of 7, because now these values are counted. So now we have a 9 here. So that's the simple count function. It counts all the values except the real blank values. But if we want to count these blank values still, what would we do? So in that case, we could use the count, because that is counting all the values in our table. So when used to count row function, let's remove that in here and look at the syntax of the count rows, and there we see that it's not a column anymore, but now it's the whole table. Why is that? Because the number of rows in one table is the same in each column. So if we have a table with 2 columns, the number of rows in these 2 columns are always the same, of course. So that's why the input here is only the whole table. So let's use that sample table in here, and then the result should also be a 9 now. So that's here the count rows. That is just very simple, and counting just the number of rows in the table. In our case, we have 9 rows, and it doesn't matter what is in there, if it's blanks or if it's logical values, doesn't actually matter. So if we only want to count the rows, no matter what is in there, we can easily use the count rows. Now there might be something like false and true values in there. And what happens if we want to count these values now? So we might be thinking, okay, what is the problem with that? Let's just have a look what happens if we use the normal account function on our account sample column, to which has the logical values in it. Then you will see that there will be a problem. And if we click on some details, then we see that there are some calculation errors. The function count cannot work with values of type boolean. Boolean values are true and false. So the logical values and the count function cannot work with these kinds of values. So if we have values like that in our column, we have to use another function, and that is the count a function. So if we use count a function, let's see what happens now. So now again it works, and we can also use normal columns in here with the count a function, and it works as well. So the count a function is able to work with all the values we have, including the logical true and false values, whereas the count function cannot work with true and false values. What can we do now if we only want to know how many different values are in our table? So in our case, let's have a look at our table again. We have 1, 2, 3, 5 different values, but we have 9 rows. So if we want to know how many different values we have, we can obviously use the distinct count function. So let's just quickly have a look what the result of this distinct count function will be. So distinct count expects also a column name like our column 1. And now have 6. If we use this sample column, the empty value, then we'll also have 6 values, because our empty value here is counted also as a distinct values. That's pretty straightforward. How to use the distinct count function? It's when we want to use distinct values in our column. And last but not least, there is also the count link. We want to only count the blank values, then we can use the count blank function, which expects also the column name. So in this first case, let's count this column where we have blank values included. So we will see result of two blank values in our sample column 1. So important thing to remember is that when you want to use logic or values, uh, then you can use the count a function, and the same applies for the average a function. So we can also calculate the average a function. So we can also use that in such cases to be easily able to just use the average function most important really, and that's why I showed the example with the count here. Could have the count function and maybe want to use to count a function in some context, or the count blanks, or even the control function. So these different versions of these count functions, and the COUNTX as well as the AVERAGEX and the SUMX function, these are very important, and we'll have a closer look at them later on.
Okay, so now we already had a look at the basic use of these aggregation functions. Now you want to step things a little bit up and go to the a little bit more advanced but also extremely important different kinds of versions of these aggregation functions, and that is the versions with the x in the end. So for example, the SUMX or the AVERAGEX function will do this with our example of our sales table. Here we have already the revenue calculated as a calculated column. So let's have a look at this column in our data view. So if we are in the data view, and we are seeing now that here the revenue, and we click on the column to see how it's calculated. Of course, the revenue is calculated as the quantity times the price. Now that's also possible to do with a measure, but you really have to know what you are doing. Otherwise, you will end up doing something you don't intend to do. So we'll look at two ways of creating this revenue with a measure. Okay, so the first one is not correct, but it's typically thought to be possible. And the other way is the correct way, and that is with the SUMX function. We'll have a look at how this SUMX function works. But now let's just use first the way that most people use in the beginning, which is unfortunately not possible. So for that, let's move back to our report section, and we are create a new measure in our measure table. So we click on new measure, and we'll call it revenue measure. And of course we want to create a sum, because in measures we always have to create an aggregation function. So we have to sum, for example, and we can sum, of course, we want to calculate the revenue. So quantity times price. So let's type quantity perfect. Here we have the quantity, and now what we want to do is we want to multiply that with the price. But we see with the auto completion already, that is, this is not the correct syntax. And also here we see that the sum function expects only a column name, so we cannot do that. So the alternative, what we have might do is then just type here times, and then maybe some again, and now we can use the price. But of course, probably you have already noticed that that's not exactly the result we want to have.
And if we start to calculate that and we visualize that, then we will quickly see that the result is not correct. So we are here at 10 million, and that is obviously not what we want. So to compare that, let's use the real revenue. So we can also visualize this as a curve. So we can compare that a little bit more easily. So here we have 11 million, and here we have 140,000 around about. Of course, when we go back to our data view and we have a look at what should be the calculated versus what we have calculated, then we see that in our the correct way would be to calculate the first in each row the quantity times the price, which is this result, and then this for each row first quantity times price, and then after that has been calculated, then we'll take the sum. So it's first the multiplication of these two, and then the result of these summed up. So the order of that is very important, and what we have just done is not exactly the same, because we have first calculated the sum of the whole quantity, and after that we have calculated the sum of the all prices, and then we have multiplied that. So that's how the aggregation functions work, but that's not what we want. So that's why most people think that this kind of calculation is only possible with a calculated column, but in fact it's very possible to do that with a measure, and it's actually a very good way to do that. So we'll be doing is now create this measure, and it is with the SUMX function. So we can just use our revenue measure, and we can use the SUMX function. So let's have a look what this function is doing first. It's expecting a table that is calculated in which is very different from the normal sum function, and after that we can use an expression, and that could be something like column 1 times column 2. And what this SUMX function is doing then, it's returning the sum of an expression evaluated for each row in a table. So what does that mean? First we specify our table. After that we can now specify the expression. So in our case we can just use now the quantity times the price, so that so that means now the first row first for each row this expression is calculated, and then we'll do this for all the rows in our sales table. So the first step is always on the row level, that we calculate this expression quantity times price, and then after that has been calculated and stored in the memory, we can calculate the sum of it. So let's close that parenthesis and have a look now to our report section to make sure that now we have the correct result. So it is very common that we have to use to evaluate some expression on a row level. So for example, the quantity times to price, and in that case we can use the SUMX function, or we can also use, for example, the AVERAGEX function, or another aggregation function based on our row level. So if we look at this measure versus our calculated column for the revenue, we noticed the difference, that this calculated column has to sit in our side of the table, whereas for the measure it doesn't matter where it is, because it's depending on the context that is used in. Now the concept of this context is extremely important in Power BI, and it's very fundamental to really understand how measures work. and so we can really work with these measures. So let's have a really close look at the context and what we have to consider to really understand the way measures work, to be able to use them in the correct and effective way. So now we really want to dive deep into understanding how measures work. And to begin with that, I want to talk about some of the differences from calculating with Excel versus Power BI, because a lot of people probably have already been worked with Excel, and many times they get a little bit confused because they are thinking in a way you think in Excel. So in Excel, everything is about sales. So we have a price in a certain cell, and we have the here the quantity in a certain cell. So if we want to calculate the revenue here, we would just also use and reference the cells. So for example, we could calculate the quantity which is in certain cell G2, and then we could multiply that, for example, with another cell. So we would calculate the multiple of this cell and this cell, and the result would be also in a new cell and only in the cell. So everything is about cell in Excel, whereas in Power BI, something like cells, this concept in Power BI doesn't exist. uh, in Power BI, everything is about tables and columns. So we can have a great look at that in our data view, where we always can see that we have here these columns, and we have these columns combined in a tables. So also, if we have a look at our measures, then we also see that here are always reference the columns. So there's a basics thing, but it's very important to have this mindset that we are working always with columns and tables, so that we don't get confused with concept of sales which we use in Excel. Another key concept that we have to be aware of is that in Power BI, with the measures, everything is about context. What does that context mean? So, for example, in this case, we have the measure one. We also use, for example, our revenue measure, and we can just drag that into their values here and remove our first measure. And now we see that here the measure is calculated based on what we have visualized here in our axis. So here we have two products, and now it's calculated for each of the product. If we visualize that only like that, and then we have only the total sum of the revenue. And we can also use, of course, external filters. So we could also use, for example, our customer ID, and um, then we could also use this as a filter, for example, and we could limit our calculations to a certain range of customer ID. And most clearly, this concept is understood in this kind of table visualizations. So when we use here again the revenue measure, then we also see how that for each of these customer ID, the revenue is calculated. So in this case, for the first of our rows, the context is that we are considering only customer ID number one. So this measure is only taking into consideration the customer IDs number one. That is what we mean with context. So now to wrap things up, we have to consider the difference in Power BI versus Excel, which is firstly that we don't work with cells, but we always work with columns and tables. And second thing is that the context in Power BI is absolutely important and fundamental, And this context consists of a couple of components. So first we have filter context, second we have the row context. So when we want to understand the calculations of the measures, we have to understand the filter context. The filter context is that very fundamental concept that helps us to understand how measures are calculated. So we have two ways of filtering. When we see, for example, this calculation here that is calculated with the revenue measure, then we have external filtering that is being applied. For example, we can select here a certain employee, and we see that here the results will change, or we can also select certain products, and then we see also that now these external filters have an impact on this calculation here, that that is the first building block of our filter context. Okay, so these are the external filters that filter on our measures here. The second thing that has an impact is within our visualization. So in our case, it's depending on which other column is the measure here used. So in our case, we have also the customer ID. That means, for example, here in the first row, we have the customer ID number one, and then this measure is calculated based on all this data that has customer ID number one. Let's have a look at to our data table. So the first step that Power BI is always doing is checking which data is in our context. So for example, if we have in our context customer ID number one, Power BI is selecting internally which is the customer ID number one. And so in this case, we have here 8 rows or data, and then just in the second step, Power BI is now performing the measure only on this set of data, and then the result of that Power BI calculates, and the results in is 90 in this case. So just keep in mind that there are always these two steps. The first step is always evaluating what is the context, so which data is this you are applying to. In our case, for example, your customer ID, or customer number one, or customer number two, or here in this case the products, and then after that the result is calculated for each of these contexts. And I think it's very good to take this into consideration always when you create and work with measures. But I also want to mention that I don't think it's necessary to get too tangled up in this and to get a lot of headache with that. Just try to consider that and be considerate about that if you are working with these measures now. Okay, so now we have talked about the filter context. There is also another different kind of context, that is the so-called row context. Now in this lecture, let's talk about the row context. We have already actually worked a little bit in the row context, and that is with the SUMX function. So we talked about row context when we use these x functions. So that is SUMX functions, or for example AVERAGEX functions. And that means that a certain expression like the quantity times the price is first calculated for each row. So if we look in our data view, we could first calculate for each of the rows, and let's remove here our filter again to select our here first of each row, this expression is calculated. So the quantity times price, and the result of each of these rows of these multiplies is then saved in memory in Power BI. So Power BI remembers that result, and after that
in the second step only, Power BI is summing these results up, and what is taking the average depending on which measures we use. So that's another type of calculation, and this is what we mean when we are talking about the row context. And that's a little bit more difficult to Power BI to calculate, because each of these results have to be stored in memory, and afterwards it's been aggregated. So in fact, if we are using just a very simple SUMX function, for example, let's make a little example of that. So if we just use a very simple SUMX function, there is no different in the result of our calculations. So if we use, let's say, example SUMX, and we use just the SUMX function, and we want to calculate, for example, the products and table, and we want to just calculate the price, only one column, then the expression is only this column, so the value that is in this column. And then we see here there would be no difference in a normal sum. So if we calculate just like this, so that would be mainly the same result as if we would only use the sum function and then would just aggregate the price. But the only difference is that the sum function is more difficult to calculate, and so if it's only a very simple calculation and we can use sum function, then we should also stick to the basic version of our aggregation functions without the x. So now we know what we mean when we are talking about the row context, that we talked about our aggregation functions with the x afterwards. So we evaluate an expression for each row in a table. So now we have one thing left that plays a role in our calculation, and that has to do with our model. So now we have already talked about the filter context as well as the row context. Now let's talk about the data model and how it's influencing and how it's important regarding the calculations of our measures. So you might be already familiar with how the data model works in Power BI. And then you can just use this lecture as a short reminder of what you might already know. So in Power BI, the data model is absolutely key because we might have a couple of different tables in our model. So for example, we have here the sales table as well as the customer table, and this might have a connection to each other, and we might be able to use these tables together. So for example, we can use the customer name of the customer table together with the revenue or any other column of this sales table. So like that, we can use these two columns in one visualization, and that's possible because we have the connection in our data model. So let's have a look how our data model works. So we are now in the model view, and we see now here our model. Basically we have here our main table. So we have all the information about all the transactions, so we call this table our effect table. And we have also here, for example, let's say our customer table, and we see that these two tables are connected via the column customer ID. So how does this actually work? So we have here additional information about our customers. So for example, we have here in the sales table a certain customer ID. Let's say customer ID number 547, and then as these two columns are connected, Power BI can have a look into the other table, so the customer table. and then it looks at 547 in this table, and it finds the information that this customer ID belongs to the customer with this name, so on so forth. So like that we can take information from another table, for example the customer table, and use that information also here in this table. When we have a visualization that is taking here information from two different tables, so that's why it's important to always consider our model when we are working with these measures, because very often when something is not working the way we are expecting it to work, then it has to do with our data model. So it happens a lot that some people tell me some things are not working, and then I see, for example, there is no connection to a certain table that we have in our model. So always check then if something is not working the way you think, and then it should work, and then check your model if everything is correct there. So that's it for the model and for the section with the context. Now we have everything we need to move on to the most important and most interesting function in my opinion, and that's the whole universe of the calculate function.
So right now we have already created a somewhat complex measure, and it could be even a little bit more complex. So for example, it could be that we want to use here in our revenue filtered measure another filter function. So for example, we have here already one function, and then we could possibly also want to filter in another table than the products table. So for example, say that we also want to filter in our location table. So we could say we want to filter in the location table, and we want to use as an expression, for example, let's say we want to consider only these products that have been sold in a state of Arizona, for example. So let's create that and say we want to have the state that is equal to Arizona. So we have now a little bit of complex measure, and that is not easy to read for anyone. So in order to make that a bit more readable, which can be quite important, especially if you want to have a look at your measure in the future again, we could use the formatting. So we can use when we press and hold shift together with enter. So we hold the shift and then we press enter. Like that we can move our text into the next line. So we can do that, and we can also use the tab key to make some indenting, and we can like that structure our measure in a way that is easier to read for us. So for example, we could say here again, holding shift, pressing enter, and moving into the next line here again. So there is no set in stone way of how to structure it, but the thing to consider is mainly that it is easy to read for you. So just put a little bit of thought into that. For example, how I do it is whenever there's a new logical book. For example, here we have the filter function, of course. There's in a new line, and then I would make another line here, and I would also use some indenting here to have this condition, and we could also make here for this next filter another one, and we could also, for example, use some indenting like that. So now it's a little bit more easy to read fast. So now we have here this measure, then we have here the first filter on the products table with this condition, and then we have the second filter with the filtering on the location. So that's something, especially if your measures get longer and more complex. That helps you to understand and to re-review your measure later on as well. Another thing that is important to do when you have more complex measure is to comment your measures. So we can use commenting by typing two forward slashes, and like that we see that the color is now getting green. That indicates a comment. So when we write a comment, this comment is not being executed. So this text here is not being executed, but it helps us to understand the formula. For example, if we look at it in 2x later, so we could write a comment about our function. This function is filtering by the products and the block creation, and is calculating the revenue that is filtered. For example, so you can place this comment anywhere, and it always works like that. For example, we could also write that here after our executed formula, and then just everything that is after this line, after these two forward slashes, everything will not be executed until we move again in the next line. So this means it's a single line comment always. If we want to do that in the beginning of the formula, we could also place that in here in the beginning of this formula. And we could also use a couple of lines, then we would have to write another two forward slashes. So that will remind your colleagues and also your future self on what you have done and what you have intended to do with this measure. So in this lecture, we want to have a look on another very interesting table function, and together with an interesting use case of this function, and that is the so-called values function. So with this values function, let's move to our data view to have a better understanding of what this function is doing. So we could look at our date table, and within our date table we have, for example, our months, our weekdays, and so on. But we see that we have here July a couple of times, so actually many times. And also we have maybe July for the different kind of years, and there might be some cases where we are interested in having distinct table of the weekdays, for example. So with only 7 values starting from Monday and ending in Sunday. So we could do this our values function, and the values function is the tables function. So therefore we click here on new table. Let's call the table values example, and we type this values function. See already here the description of this values function, and we will first also have a look at the syntax of this table. In this values function, we can enter a table name or a column name. When a column name is entered, it will be only a single column returned within our new table, and this table consists of this column with unique distinct values. Let's have a look first at what that is doing. So we could, for example, create here the distinct table of our weekdays, and then we could get only here 7 lines of the different weekdays. So at this point you might be asking, in reality, where can I use this function? And therefore let's have a look at an example of where we can use this values function and how we can use it. So in our example, let's consider here our revenue measure. Again, we have here all our customers and how much revenue they have produced or created. And it might be also interesting for us to see what is the monthly average each of these customers is producing. So this we don't have in our data because it's something pretty specific. So we could do this with the values function. So let's create a new measure and do this. So we go to our measures table and create here a new measure. So what we will be doing, first giving a name, that is the monthly average revenue. So monthly average revenue. So we use the average function, but not the normal average function, but we'll use the AVERAGEX function. Why we'll be doing this, we'll of course have a look at now. But first let's look at the syntax. We remember that the AVERAGEX function, like SUMX function and all the function with the x in the end, and they need as an input table. So whenever a function is expecting a table as an input, you can also use a table function, because the output of the table function in fact is just a table. So as the values function, this table function, we could also use here, use this values function, and so we could create here the values function, and we could insert now the month, but not the month itself, but we will insert the month with the year. So let me first create this measure, and then we will have a closer look also how this exactly works. So now we have just entered the distinct values of the months and the year. Let's remove that, by the way. So our average x function expects an expression. Then expression we could also use an already created measure. So we will use the revenue measure. So let's close again the parentheses, and now let's have a closer look at how this measure works now. To have a better understanding, let's again move to our data view, which is perfect for understanding how things work. So let's also now change this created table in a way that we also use here the month together with the year. So we have here also the year, months, and now we see here all the months together with the year. So that is our distinct list of that. So now let's think about how our measure works. So as an input in our average x function, we use exactly this table. So what the average x function is doing, as we remember, it's evaluating a measure in a row based context. That means that in the first step, always our measure, which is the revenue, so the sum of the revenue is calculated in the first step, and net that for each of our rows. So we have the revenue for May, we have the revenue for June, for each of these months, and after that is done, the second step, we are calculate the average of that. So all these values have been memorized in memory, and then we can calculate the average of that. And so that is the actually what our monthly average function is doing. So first here we specify the table that we want to use as our context, and then we have now here that measure. So let's have a look at the result of that measure. Now we are just move our measure in our new table, and we could also make the formatting a little bit more nice. So we use here again the English currency. So now we have here the monthly average revenue. So if we would like to calculate something else than the monthly average, we could just change here this values function. For example, let's move back to our data view,
and look at our date table. So for example, we could also want to calculate the quarterly revenue average. So we want to use here this column, use the values function, and then we would get the quarterly average with just very simple dust method. So we'll just here use the quarter, year and quarter together. So then we would just get the quarterly average. So that's a practical example of how we can use the values function together with some SUMX or AVERAGEX function.
And let's now have a look at another very interesting function that we can combine with our average x function, and that is the rank x function. So to have an first example of that, let's create again new measure for that, and we'll create a new measure. Let's call that our ranking by quarterly average, and we are used to rank x function. So the rank x function, what this function is doing is it is returning the rank of an expression evaluated in the current context. To understand better what this means after we have created our example. So what this rank x function is expecting is of course first a table. So in our case, we just want to do these. We want to create a ranking of our customers by who has the highest quarterly average revenue. So the customer with the highest revenue should have ranking number one, and the customer with the lowest average revenue should have the lowest ranking. So first we have to specify the table that we want to do the ranking in. So we want to rank our customers. Therefore, we use the customer table. So we use the customer table, and now we have to specify the expression that our ranking is based on. So we want to rank them by the quarterly average revenue. So therefore we can use, for example, just our already created measure. We remember an expression can always also be just a measure. So the other things are just optional and not that important. So we could, for example, add here the order, whether we want to sort our ranking in ascending order or in descending order. The default will you will always be descending if you don't write anything, but if we want to make it the other way around, then we could also specify here ascending, or if we just want to make it a little bit more understandable and readable, then we could also specify it. But in our case we don't need that right now. So now let's just see what this measure result like. So we have created our measure, and now want to drag it in here and see what the result will, and we'll be surprised what the result is. So that is not what we want. So here now everywhere is 1, and that is really not what we want. So let's have a look at what our mistake was. Let's move that a little bit over here, and if we think about what this function is doing, we might understand why here there's always a 1. So the ranking always be created based on our context. So in this context, there is only one customer. So here this context is filtered down to only this single customer. So of course he will be the number one ranked customer because there is only one customer, and the same goes for the other customers. So therefore there will only be one for each of the customers in each of these lines. So therefore we have to modify here this table what we insert. So we want to apply some function we already know, and that is all function. So that means that always for our ranking, our customers are considered no matter what the context here is. So that means our base table
our whole population is always here, the whole customer table, and then we will calculate the ranking for our specific context. So now let's see how the result is changing now. So now we see that this is closer to what we actually want to have. So if we order that average revenue in descending order, we will see here now our making ranking, and that is totally correct. So that's what we want to have and can be very useful. Later on, we'll see a great application of what we can do with this ranking now. But for now, let's have a look at how this measure interacts with some external filtering. So for example, we could use the day table, and for example, here our year, and use some filtering on that. So we could say now we have considered all the years, but for example here maybe we want to only consider 2 years, and then we see okay, now maybe there are some other customers and the order might change. So for example, if we have it like this, factor is on number 1, and if we change it, it will be another customer. Of course, that makes sense because we have changed the context, and also now our ranking will be different. So that is what we would expect, and what in most cases is what we actually also want. But there might be some cases where we, for example, want that our quarterly or our total revenue is changing depending on how we are filtering, but we want to have that this ranking is always considering all the years. So no matter what we are filtering here, we want to see always the total ranking that is considering all the years. So how can we do that? So I give you a moment to think about that, and also we can have a look at our measure here. And so I give you a little hint on how we can do it. Already learned about a function where we can change the context. So of course we would use the calculate function to change the context for here the years. So let's see how we would do that. We also know how already we can format, so we will use now calculate function here at the beginning, and our expression is of course here our ranking in our case. But we would also now add here some change in our context. So what we would like to do is we would always consider the whole years. So no matter what we are doing anywhere in our visuals with any filtering, we would like to have that always the whole years are considered. So therefore we just write the year in our all function. So let's see now how this affects our measure. So now of course we have here this is the person, the highest quarterly average, and if we change that a little bit, then we see that there is another person with the highest quarterly average revenue within our period. But in total, we see that this person has not the highest quarterly average in all the years. It would be, of course, here this person. But if we limit the quarterly average only to this area, he is actually not the highest one. So that's something. That's an interesting variation that we can use. So let's look at another example. So it could be that we want to have our customer filter, and we want to select one customer, maybe a group of customers, and then we want to see how they are ranked. But it would be nice if we select a couple of them to not have this like or not continuous ranking. So it would be nice if this would be a little bit more continuous. So no one would be him, number 2 would be him, number 3 would be him. So if that would be 1 2 3 4 5 6, so it would be a little bit easier for us to read and also to understand. So let's have a look how we can change again context to get the result that we want to have.
So we have now here our measure, and we want to change now the context for our customers, and we can do this also here. So that means that we are not always considering all the customers, but we consider all the customers except the one that we have filtered here. So filtering should still be possible. That means we have to use a function we already know, and that is the all selected function. So let's use that and have a look at the result now. So that is now the perfect result that we want to have in our case. So now we have some kind of interesting way of ranking our customers. But what would be an interesting use case of it? So let's have a look at some very interesting practical use case of that function. So in the last lecture, we have created a ranking measure, that is ranking our customers based on average revenue. So now some interesting use case of that be that we want to have some filtering based on this ranking. So you would want to maybe create a filter that is only taking here the top 10 customers ranked by the quarterly average, or for example the top 10 or the top 20 or the top 40. So we would have some power and some control over how many customers we want to see here. So let's look at how we can do that. So first we want to create a little helpful table. So we want to create this helper table by entering new data. So let's click here on new data. Let's call that table, that is our top and filter table, and we want to add two columns. The first one is the actually top and value, and the second one is the top and name. So that is the name that will be displayed in our filter. So here we can specify what the end value will be. So top 3, top 5, top 10 for example. So let's do that like this: top 3, top 5, top 10, top 20, top 50 for example. So we can add here the values that we want to have our top and ranking: top 3, top 10, top 5, and we can now here specify a name. However, we want to have that, for example, the top 3, the top 5, or top 10, top 10, and then top 20, top 50, and so that's already our table that we can use now here to filter. So what we will be doing is that we use here this column in the filter, so that we would be the column that is visible in our filter, and we will use here these values to compare them against our ranking. So we will show only the values that are smaller than 3 smaller or equal than 3 smaller or equal in 5, and so on. So let's now click on load to create this table and see now how can we create our measure with it. So now we have our table. Let's look at it. We have it here in the top and filtering. We could use the name, and we could also create a filter of it. So now one thing that is a little bit disturbing is that here order is not a numerical way, but it is based on the text. So this is a text and it will be alphabetical order, and we want to change that. So we ordered it by another column, so it will be in the right correct order. So that means we can order this column, our column that we use here in the filter, and sort it by another value. So for example, top 5 top n value, which is 3, 5, 10, 20, 50. So now it will be in the right order. But of course now our measure
filtering is not working yet. For that, I have to create a new measure that is using here these values. So let's click on our measure table and create a new measure, and let's call that measure top n filter out revenue. And so we will use for that a simple if statement. So and if statement, the function if is using a condition, so a logical test, and is checking whether this condition is met and returns one result if the logical test is true, or and optional another result if the condition is not met. So let's see how we can use this function to do what we want to have. So we want to make the logical test, and that is that we want to check whether the ranking is smaller or equal than our value. So we want to check whether that is smaller or equal than our top n value. But as we enter here top n, we see that this column is not found, obviously because it's a column and there can be couple of values, so it's not so clear how this should be compared. If there are a couple of values, so we need some kind of aggregation function or some kind of function. One possibility would be to use the value function. It's not an ideal way, and we will see later on why, but first let's start with the value function. This is possible and we can do that. So we would use here the column name, which would be top n values. We want to compare against the selected values that we have here. And if this is true, so if ranking is smaller than the selected value here, then we want to show, of course, the revenue. For example, revenue, we could choose now the revenue or the quarterly average revenue, whatever we want to show. So in our case, we could, for example, just use this one, and if the result is not true, we don't want to show anything. So then we don't want to show these values, and therefore we just enter blank here. So we enter the blank function, and then after we have done that, we are already finished with our measure. So let's have a look now on how this measure works. Obviously, we want to deselect here these customers, so we have now all customers in our table. So let's change that also back to everything and have a look at what our measure is doing. So we want to use the top and filtered revenue, drag it in here, and we see already now that now as top 3 is selected, we see here the top 3 customers based on the quarterly revenue. Let's also change first here these values to the currency by selecting our measure and change here the currency to dollars. So we can also now, as we have checked that is correct, values are the same and we only see here these values, could now remove all the other values to get rid of them. So let's get rid of them, rid of the revenue, this one, and also we want to remove this ranking. So now we would only see here these values that we have selected. So that is now what we want to here. But now let's have a look at how these values function we used. It's not always appropriate because it might be that someone could think, let's check if I can select 2 of them, and then we would get some problem here. So maybe we want to find a way around that and avoid it. So obviously, when we have selected 2 of these values and we have a look at our measure again, then you see that here there would be now two values selected, and it's not possible to compare the ranking with two values. So we would have to use another function, and that would be an aggregation function, so that we can aggregate these functions. And something that would make a lot of sense in my opinion would be to use here the max function. So then the only highest value would be selected. In our case it would be 20. So if we select two of them, always the one work that is the highest one. So let's see what happens now. We should see now here the top 20 values, and as we move down this seems to work. If we do selected, it will be the top 5. If we add the 10, it will be the top 10. And okay, so there's a great way to use a top and filter for our reports. Another simple alternative to that be to visualize our filter with our top and values. So with the real numbers, and we could do that in this filtering. So we could use a slicer like that. So we could limit now here our calculations based on what are selecting here. So of course it's depending on which values we have in our table, but if we want to add a couple of values, we could easily do that. So that's how we can use the ranked function together with a really nice top and filtering. So if we have a look at our measure, we see that now our measure getting more complex and more complicated. One really nice way to handle more complex measure is to work with variables.
Now we'll have a look at the most commonly or one of the most commonly used function, which is the dates to month, quarter to month, or year to month function. So let's create a new measure and then have a look at how we use this function and what this function is actually doing and how we can use it. So we again put this measure into our key measures table, create a new measure. So let's change its name to month to date, for example. And of course, we want to use again our calculate function because we want to calculate an expression which is our revenue measure, and we want to change the context how this measure is calculated with this time intelligence function. So we want to create this function with the dates mtd function. So what is this function doing? We see already here this description. It returns a set of dates in the month up to the current date. So we will have a look at this, what this is doing more precisely when we are finished with this formula, and we can see it here in visualize. Then it will be a lot easier to understand what this function is doing. But first we want to insert here the dates column, which is in our case this is our column date within our date table. So we want to use this, and that's all we need within our function. So let's visualize the set, and now let's move that into our table. And also what we'd like to do to make it a little bit easy to read fast, we want to remove this date at example function, and also we could, for example, change back here for our hierarchy to our normal dates. Okay, and then one last thing we would like to do is to change again here the currency. So now what is this function doing? So we see now here the first value is the same, the second value is also the same. But now as we move on, this is adding up each value from the past. So for example, this value 66 is the total of the values that have been here in the past. So we will sum up all the values until we finished the month. So for example, it's all adding up till the 31st, and then once we started the new month, we start again from zero from the first day here, and then again it's adding up, and then until we reach the end of the month again. That is what is meant with month to date. So it's even easier to see that when we visualize that in a line chart, for example. So therefore, let's use this chart as an example, month to date. And of course, this only makes sense, this visual, if we use here in our axis something that is more granular than months, because everything will be added up to the months. So in our case, let's look at the dates, for example. Now we could also change here years, so we see a little bit closer. So now here we see for each of the months, we sum it up until we reach the end of the month, and then we start again from the first day, and everything will be added up, and then we'll be start again and everything will be added up, and then we'll start again. So that's for this measure is doing. And another version of this measure would be to use not the month to date, but for example, we could now easily also use, for example, here the quarter to date function or the year to date function. So for example, if we use this one, then we will see everything is added up for the quarters, and then when we start again with the new quarter, and it start again from the beginning, all the same the same for year function, and then we could again see a couple of years. So you see that this function is pretty easy to use, and then can give you some really insight into it. We have used this calculate function and changed the context with the dates year to date function. But there is also another way. Now we'll learn how we can do the same with another function which looks a little bit easier, but in my opinion, still the calculate function is the better version, because we are more flexible with the calculate function, and we will also see now in the practical way why I prefer here this method of using the calculate function. So let's have a look to what the other function would be. So we see that we have used here our dates month to dates and date quarter to date or dates year to date function that we have used to change the context in our calculate function. And we also see here that this function returns a table, and this table we use to change the context in the calculate function. So there is also another function that looks really similar, and that is here our total year to date function. And this function evaluates the year to date value of the expression in the current context. So with this function, we don't need the calculate function, so we can calculate the same result in only one function. So now that looks a lot easier, and therefore a lot of people might think this is the better way to do it, but in my opinion we are more flexible with the calculate function, as I said. So therefore now let's have a look on how we can replicate the same result with this total year to date function, and then also have a look on why I prefer the method with the calculate function. So let's move to Power BI, and now we want to replicate the same result. Therefore let's create a new measure, and we want to call that year to date total. Okay, and we want to use the total year to date function, and this looks a lot like in the calculate function, because here we use need to specify first an expression that is calculated. For example, we could use an aggregate function like the sum function, and then we can enter a column that we want to aggregate. But as we remember, we can also just use a measure that already includes an aggregate function. So for example, in our case, of course, we want to calculate the revenue. Now we need to specify, because it's a time intelligence function, of course, therefore we need to specify which is our date column. So we use the same date column as we have used in our former measure, and then we can enter even some filter. So this comes even really close to the calculate function, because with this filter now we could even change here also the context of this total year to date function, which is actually pretty great. But we'll see how still the calculate function is the better way later on. And also after we enter the filter or no filter, we can here specify the end of the year by default. Of course, this is 31st of December, but we could enter also another year here. But in our case, we don't need that, and we just want to use here this simple version. So let's have a look and then also compare the two measures that we have created. So here in this visual, we have our year to date that we have created in the last lecture, and now we want to see how this new version looks like. So we move it in here and we see that there is still only one line. This is because the result is exactly the same, which proves that this function works. But now what happens if we want to change this context of our function? So for example, in our calculate function, as we can see here, we can easily add another filter. So for example, we could say that we want to filter, let's use a filter function, and we want to filter on the customer table, and we want to see, for example, only the customers with a customer ID that is greater than 200, for example. So we can easily change the context here and see that the result is now different. But as you remember, in our total year to date function, we also have the possibility to add a filter. So actually we can also here do the exact same thing. And then let's have a look on the result, and we see now that again now we can achieve the same thing with the total year to date function. So I have to admit that this is actually pretty good, and we can in a lot of cases really use this total year to date function even if we want to add a second filter to it. But now what happens if and that's where it's getting a bit difficult with the year to date function. What happens if we want to add a row now second filter? So here in our calculate function, as we see here, it's pretty easy for us. So we can just simply add a second filter, and for example we could say we want to look at certain employees. For example, only the employees with an ID greater than 15. Okay, this is we can easily do with our calculate function. So we are really flexible with this calculate function. Now if we move to our total year to date function and we try to add a second filter, then we see, okay, here we can only add one filter, and that's where it's getting really too complicated to achieve the same result with this total year to date function. And therefore I think the preferred method is to use the calculate function, because it's a more general approach and we can usually achieve all the most flexible results with the calculate function. Therefore, if you know how to use the calculate function, you are in most cases better off than using other functions. Even though in the first look, if you don't work very long with DAX, this looks a bit simpler. But as we move to our calculate function, and if you know how to use the calculate function, you will also think that this is not so complicated, because basically we just enter here our expression, then we change the context, so we calculate the year to date, and then we can add as many as filters as we want. So I hope you could see that it's possible to have different ways to achieve the same result, and you could also maybe see why I prefer to use the calculate function in this case over the method with the total year to date function.
So now with DAX, we have already learned how is to calculate things in a measure. But we could also use DAX to change the formatting columns. So to use a real and specific formatting and ways of rounding presenting our data. And the next lectures you will have a look these ways of formatting that we have here in DAX. So we will begin with round and in okay, rounding is not something really complicated, but there are a lot of different types of round, for example, numbers, currencies, and even for example time. So these things we have and start off the numbers. So because there are a lot of interesting things we learn about this now, and we start off here the numbers. So we will start by creating this time a new column. So the calculated column that is based on our numbers column. So we'll start by seeing what kind of different ways we have to round us. So let's call this column round as our first function, the round function. So the round function just rounds a number by a specified number of digits. So first input we can enter is the column we want to round numbers. We want to round that is our column numbers that you can see here. And the second input that is expected how many digits we want to round to. So for example, say we to round to one digit, then round up to the first digit. So let's have a look at the result, and then we'll see that this one was rounded up, this one was rounded up, as well as this one, and this one was rounded down. So this function is rounding as we have one digit, and it's also deciding to round up or to round down. So if, for example, enter here two digits, want to round digits as we already have just two digits here. Digits doesn't make sense in this case, but also, for example, round to zero digits, and this in this case we just round to the whole number. So in our case, this was rounded to 7, to 8, to 8, and to 30. But we can go even further and round -1. That means it will round up to the next tens. So we can even round 2 -2. So there is no notation yet. In that case, it was rounded down. If our numbers are closer to 0, then they are to 100. So we have really great flexibility here. But what if we want to decide whether to round up or we want to round up? So for example, if we change in one, that in some cases it will round up, and in some other cases it will round down. So, but we can also say always want to round up, for example, always want to round down. So we can do this by using the round down function. So in that case, we will always round down. So as we can see right here, the same can do the round functions, then we will obviously always round up. But what if we want to round some even or specific? Let's imagine we have some currency. So let's change the formatting here, currency, and imagine want to round, for example, the next 5 cents or the next 10 cents. Then we have some specific way to even round to some multiples. So we can do this with the m round function. And this m round function, what it's doing is returning a number rounded or desired multiple. So we use this one, can specify here again our column, and then here we can decide what is the multiple that we are rounding to. So for example, if you say want to round to 5 cents, for example, so let's see what's the result will be like. Now we see everything is rounded to 5 cents, and so here we have rounded up, and here we have rounded down. Here we have 52, 5 and 5. Okay. And you can even make some other numbers like something which might look a little bit weird, for example, to 0.12 or something like that. There's also total possible, and we have really have a great flexibility. What if now if we want to round, say again to 0.5, but don't want to round down, but always want to round up, for example. So then this doesn't work so easily with this function, but we have some function available that is doing that. So for example, we have here the floor function, and this floor function is doing exactly the same like the m round function, but it's always rounding down. So in this case, for example, the customer doesn't have a mode, always do round down a certain multiple. So in this case, the result is almost the same, except for some cases it's not rounded up, but it's rounded down, such as in this row here. And of course, the same thing we have also the ceiling function, that is just the exact same thing, just it's rounding the number instead of rounding down. So you see, you have really great flexibility over how specific you want to round your numbers. The great thing now is you can even use these functions with other formats or other data types such as dates and also times. So let's have a look now at how it's like when we are not rounding numbers, but for example, we are rounding time. So let's also create a new column and use the same functions that we have also used with the numbers, just to quickly see that it works the same way. So for example, we say here round time and want to use let's say mround function, and here it's really great that we can also enter our time column, and here we can now enter the multiple. But how do we enter the multiple? So the great thing here is that you can enter it in a way that is really intuitive. So say want to round for 1 hour, so then like this. First one is always the hour, and the second one is always the minutes. You can enter here the seconds, but in our case we just want to add on our WhatsApp, and forgot to close the parentheses, which Power BI text can autocomplete here easily. Now also be surprised about this little bit weird looking result. Don't worry about that. This is just because we have here the data types as a decimal, but you can also change that to time, and then the decimal will also change to the time form. Okay, and then the result is really what we are expecting. So if we to round, example 5 minutes, then we can do this like that, and you are rounding to 5 minutes. Of course, we can also round just to, for example, a couple of seconds, and then we can add seconds as well, then we could round it to the next 30 seconds. And same thing we can also do ceiling and the for function. So if we don't want to round up, but we want to round down, we can use the for function, and we can use here also the same syntax and the same expressions. So in this case, with the for function, just do the same thing, just we will round down always. So here we see now every wire was round down the next multiples. So you see that you have a lot of flexibility even with different data types, and you can really specify very specifically how you want to round your columns, such as numbers and time as well. So whenever you want to have some real visual round, you can use the round functions. So in the last lecture, we have already seen how can we round numbers, time, and currency in a very individual and specific way. But we can also now choose a very custom format of our numbers, time, and date. So we will learn in this section how we can use this format function to change to a very specific format we have chosen. So we learn how we can change the format of numbers, of dates, and times. And there are two ways to change the format in this format function. The first one is to use predefined formats, and you can use this for numbers as well as for date and time. And the second way is a little bit more specific, and that is to choose a very custom format of our numbers, dates, and times. In this first lecture, we will look at the predefined formats for numbers, which is basically simple. We can have a look at the formats here. Here we see the format specifications, and here the description how this format looks like. But I think the best way to understand and to see is to see it in this format. So therefore, let's move to Power BI and see how we can use this format. So we have here a new table, numbers, column, a lot of different values. And now we will have a look at how we can change here the format of these numbers. So therefore, let's create a new column, and let's see what form it we can use format column, and of course use our format function. So this format function, we have to first of course specify the column. In our case, it's the number format, and here we can choose now the format. So how we can choose a predefined format? So we can easily do that by just typing quotes, the double quotes, and then just entering the format specification we want to have. For example, use the general number format, and then we can just enter and finish, and then we see that we have now this kind of format that is a little bit different from our original. So this is a really general and basic format which always displays the whole number. And also here the points in our decimal separators. So this is a pretty basic one, but we could for example also use the currency format. And this currency format is really interesting because now the numbers are always displayed two decimal places, dollar sign beginning. And for the negative values, we see that there is this parenthesis, and also we have here thousand separate. So always we have, if we have a couple of thousands, we have here this comma separated. So for example, here also we have 3000, so we have 3 comma then the rest of the round. So that's an interesting one. But also say we have something like true, false, And what happens there that is that we have true whenever the value is not 0 and false when always when the value is 0. So this is how we can use this format, and can even modify that if we want. So we, for example, test that an if statement. So say, for example, a logical test, say check if the number is smaller than 0, and when it is, then just use 0, and then when this is not smaller than 0, just use the number itself, and then we want to use the format function with this function. So it means that we want to use this statement in our column here. So now we have this as our number, which is either 0, is smaller than 0, and the number itself if it's greater than 0 or 0 as well. So now let's see what the result looks like now. So now we have the false also for the negative values. So in my opinion, it's really interesting to use this function to make the format function even a little bit more specific. So what other formats use? Let's just remove that again. There are some other common thing that we can do is here to, for example, use the percent format, that is just always multiplying basically with 100, and then also displaying 2 or digital places. So 1 equals to 100%. Another way could be, for example, scientific, which is also a little bit more specific because that we have here in this type of format. So if you want to know which kind of format you can use with this predefined formats, then you can also have a look to the format function, and then there you see the predefined numeric formats. So you have these kinds of defined formats, and here also the description of how this is formatted. But as we said before, there is also a way to choose some kind of very custom format, uh, and this looks a little bit complicated, but we will look at the most important things and how we can use also this custom format in a not so complicated way. So here we have some examples of this would look like. I admit in the beginning it's like a little bit difficult, but actually it's not so difficult.
Now, as we are progressing more and more, I would like to introduce the quick measures. The quick measures we find here in our home ribbon, where we can just quickly create some predefined measures in Power BI. So we can just click there, and then we see here that we can select a calculation. For example, we can aggregate, we can use filters, we can use the time intelligence, and so on and so forth. So for example, we could say we create here the year to date total, and then we have to select, as we have to do it always, a base value. So what is the value we want to use for our calculation? For example, we usually have used the revenue, and of course also in this case we need to select a date field. So in our case, of course, this was usually the dates table. So let's have a look to the dates table and use our date column, and that's how simple we can create our quick measure. So let's have a look at the result here and just see this as our first example here. So now if we have a look into our key measures table, we see now that we have here a new measure, and that is our revenue measure year to date. And the great thing about these quick measures, I admit there are advantages and disadvantages to use them, but one great advantage is that now we can see the whole syntax and the whole formula of how this measures is created.
And like that we could even change the formula, like give it another name or just change the formula itself, and then use this quick measure as a starting point, give us maybe inspiration or to just get some practice and learn how Microsoft would, for example, create measure. At disadvantages in my opinion is that in most cases I find these formulas could be a little bit complicated. So in my opinion I would create this measure a lot simpler and not that complicated. But we'll have a closer look on this measure later on also in this section. So as I said, there are advantages and disadvantages to quick measures. In my opinion, it's okay to use them, but I think it's even a lot more important that you know how to use docs, because a lot of people might use quick measures without knowing really text, and then I don't think it's a really good idea, because you can do a lot of more things if you know how to use text, and then you can also look at this formula and really understand what this measures is doing. And also I think if you really know how to write DAX and you have some practice with it, then it's even probably quicker to create your own measures than to create a quick measure, because you can quickly write exactly what you want to do. So therefore I suggest to, yes, use this quick measure, but don't use them blindly. Use them to practice, use them to get inspiration, or to see what Microsoft would do, what is possible, and to expand your knowledge in DAX. So that's how I would suggest to use them, these quick measures, because in practice, if you know how to write DAX, you'd probably always create your own DAX. But in the beginning and to practice to get some inspiration, it's a good, in my opinion, to use also these quick measures. So let's have a look now how we can create our quick measures, and we would like to begin with the calculation of filters. So that's an easy example, and we can quickly understand how these quick measures work. So we just select the calculation that we want to calculate, and then we get these fields that we have to fill with our existing columns or with our existing measures. So as a base value, we can either use just a measure, or what we also can do is to use a column, for example. So we could, for example, use any column, but as we know, with measures we always have to use some kind of aggregation. So therefore here we have selected count, but we could also choose another calculation such as average, sum, and so on. But in our case we would like to just use this revenue measure. And now here we can use a filter. So we can just select any filter that we would like to use. For example, we could have a look in the location. For example, we could use the state and then just drop it in here, and then here we could now select a value that we want to filter to. So here we have a couple of values, for example, Alabama, Florida, and some more that we can here select. We can select multiple of these values by pressing and holding the control key. So like that we can select a couple of states. So let's have a look at the result. Click on OK, and then after these measures has created, we should see it here in our fields. Let's just have a look at the results of this, and we see already there is something calculated, and now we would like to see what this result looks like. Now we have here this result in our measure, and we can also see how our total revenue would like, and is this what we get. So now let's look at how it would look like if we have also our location visualized. So if we use the state, then now we see that here we see in each of the state always we have this value here. So this is the approach that we get when we look at our measures again, that we would expect if we don't use here a filter. So then we would see everywhere here the results of these four states combined together. So let's have a look at this function. We have, of course, our calculate function, and then we use the expression of our revenue. Then we just filter by the location state, and we say this. We could, for example, say with an equal sign and that this is an equal to a certain state, but if we'd like to use a couple of state that we would allow in our filter, then we would also use this in operator. So if the location state is equal to one of these four values, then we calculate the revenue. So the revenue of these four states is calculated together. So we could now say we would like to change a little bit, and we'd like to use here a filter. So we could use the filter, and now we have to follow the syntax, which expects here first a table. So let's choose the location, and then we have here this expression which is correct, and then we just have to close the parenthesis for this filter. So now let's have a look what the result looks like now. So now we see that we have again here the values for this California, Florida, and for the other states we don't have included here. So this is the difference that we see when we use the filter function. We could also now create another measure that is similar to our filtered value, and that is the difference from the filter value. So like this, we could just, for example, again use our revenue measure, and then we have here this balance field. So if we hover over this a little, I hear then we see the little information. So how to create lens data in the base field. So we have two options here. Either we could produce a blank in the output 2, or we could create a 0 in the calculation. So we will have a look what this would be like soon. So first let's use here this produce blanks in the output, and then we can now choose again our filter, because we want to calculate the difference from the filter's value. So therefore let's again choose the location. For example, we could just use again the states. We could use California again, and for example we can also choose again Florida. So California, we press and hold control key and then select also Florida and have a look at the results. So now we have a look and we find our created measure in the wrong table, because by chance we had just selected table and we clicked on quick new measures. So this can happen, but we can easily find it if we search here for something like difference. So we know something of the name, and then we can see now, okay, this is in the table, and we probably should move it back to our key measures table. We can do that easily by just selecting the measure and then changing here the home table. So here we can select now our key measure table. So we selected and have moved it now here in our key measure table. So let's have a look at the results. We will move it in here and check what the result would be like. So here we have mostly negative values. It looks a little bit difficult to understand what happens to now, but therefore we can now again click on our measure and understand then what happened here and what we could change to get the result we might expect. So we have here some variables. Let's make that a little bit bigger. So we have here two variables created. First one is the baseline values. That is our value, that is calculating the revenue for the states California and Florida together. So that means that if we look at our table again, for every row here, we would get the result 29,000. Because we don't have here the filter function, that means that everywhere in the context would be state is California or Florida, and therefore the value here for this variable would everywhere be 29,000, because that is the value combined for California and Florida. Then we have a second value, that is our so-called measures value. This is just our revenue without any restrictions, so this would be this value. And now what happens, we have here an if statement, that is first checking if it is blank this measure here. If it's not blank, then just subtract the 29,000 from the measure value. So therefore that means we have here, for example, in this row we have 17,000 minus 29,000, which is around about 11,000. And if there would be a blank in the measure, so if there would be a blank here, then there would be also a blank later on in our calculation. So if we would show also the values with our data that we can choose here, just click on the field and then click on show items with no data, then we would also get a blank here in the result. So now we could easily change it. So now what would change if we would have created our measure in a way that we have create as zeros in calculation. Let's create the measure again. Let's just move here and the revenue in and choose the filter, which was our location, and here it was the state. Here we selected California and Florida, and then just create the measure, and now we will see the difference. So if we move it here now, then we would see now that here in these blanks this would be treated as 0, and therefore we would always have minus 29,000 minus 29,000. So this would be the only difference here. Now let's have a look what the difference would be in the calculation. So the calculation would be pretty easy here, because now here we have no if statement, and in every row that we are in there would be always minus 29,000. So if there is no value here, this would automatically be considered as a 0. So now we have to learn a little bit about the filters here, which are pretty straightforward and not so complicated. But now let's move on to the time intelligence functions, where we see there are a lot of interesting calculations, but there are also a couple of things that we should be aware of. So we learned about how to create the quick measure for the filter calculation. Now let's move on to something that is really interesting, but also where we have to be a little bit aware, and that is to create time intelligence quick measures. So first, there is something we already know, that is the year to date total. So let's have a look how Power BI and Microsoft would create this measure. So we create here, we select the year to date total, and as a base value we would have again our revenue measure, and as the date column, of course, we use our date column from our date table. So let's just select it here and then have our measure created, and again we had this table customer selected, which was by accident, therefore we want to move it back to our key measures table. So we can just select and then just change the home table. So we would like to have the home table, that is the key measure table. And now we also notice we have already created such a measure. And then what Power BI is doing, if you have already created such a quick measure, Power BI would just call it year to date, the same name again, and then there would be a 2. If you create another one, there would be a 3. So there's something to be aware of. And now let's have a look how this measure works. So first of all, we would like to remove this table here and change it to something else. So we would like to have again our date table in this table, and then we would like to have a look on how our newly created measure works. So let's just move it in our into our table, and now we have the year to date measure here. So it's working as we expected. We can also visualize this one here, and so we see this works the way we would expect it to work. But now there will be something that is a bit surprising, because let's just change the hierarchy, because we don't like this look of this hierarchy to the normal date values. So if we want to change it, we get something that is surprising us. Here we have some problem, can't display the visual. And if we click on some seed details, we get an idea what the problem is. So we have here this error message: time intelligence quick measures can only be grouped or filtered by the Power BI provided date hierarchy. So this seems like a problem, because what if we don't like to have it like that? So we are not that flexible with that quick measure. But as we know already, some DAX, we can have a look and understand what the problem is and if we can solve it. So let's have a look at our measures. So here we see something, and that is an example of how I would not create a measure, because in my opinion this is just too complicated and not very flexible for us. Because in my opinion this is a way too complicated, I would create this lot simpler, because basically we just want to create the year to date measure. So actually this would be the only thing we would need. But now let's try what happens here. So first we start with an if statement. So this if statement is checking if we are in our date hierarchy, or if we only show the date values. So in our case, if we show here these date values, then we would like to have an error message like this: this is not within the date hierarchy. And if it's not like that, but if we are in the hierarchy, then this would be calculated with the hierarchy. And the hierarchy, we see that there is this little dot, and that means that we are within the hierarchy. So we can just remove this, because we actually don't need it, and then it works either way. So we could just remove it like this, but then of course we also have to remove this hierarchy. So now we have this simple measure that is really not that complicated. We would always do it like this, and now it works with the hierarchy and without the hierarchy. So in my opinion, there is a lot easier and a lot better. So now we can see it works like with these values, and also it work of course with the hierarchy. So now both ways would work either way. And also I want to show you a little trick when you want to create quick measures to have a little shortcut. So if you want to use this measure as your base value in your quick measure, you can just right click on it and then select on your quick new measure. And if you do that, then select some calculation. For example, we can calculate the year over year change, and then here in our base value this measure would be already selected. So it's a little shortcut. Now let's have a look what this year change over year change would look like, and how Power BI would treat that. So we can also use our date column, which is again in our date table. Just move it in here. So here we can now select the number of periods. So you want to calculate the year over year change. That means that we can select here a period. Do we want to go 1 year in the past? Do we want to go 2 year in the past? So if we want to see the value, the year over year change from 1 year, then we can just leave it like 1. Let's have a look what the results looks like in practice. So we create that. It is now here in our measures table. Let's just move that a little bit over here, and now let's also maybe select some line chart and also use in the x6 and date column. So now we see already that is about percentage values, so we can understand that a bit better if we have here our measures within, let's say, the years only, and we only want to see here the values. So we see here in our table that there was more than $10,000 more revenue. That means it was more than 200% more than last year. So 0% would be we are the same like last year, and 100% means we are double, and 200% means we are 3 times more. So this is how these measures work, and of course it also works in a deeper level. And then we would just compare the quarters, or if we even go further down, then we could compare January of last year with January of next year. So this all is possible, and we are again really flexible with it and with our representation of this measure. So we can use it in different contexts with months as well as with the dates and so on. So let's have a look on how this measures was created. So just again click on it, and we see again this message with the statement which really we don't need. So we can just remove that, and also here this parenthesis, and also we would like to remove here of course the hierarchy. But I have to say that I like that they work a lot with the variables, because that makes it really flexible, and that makes it makes a lot of sense in my opinion. So again we will look at that. If we look at that, we already understood what has been calculated here. So here first they have created a variable. They used a calculate function to calculate the revenue, and then change the context by moving this calculation 1 year back, and so 1 year in the past. So then we have here this previous year, and also we have here our base value, which is just our normal measure. So then we calculate the first difference between the current context or the current year, and then the same for the last year, and then this would be just divided by the last year, so we get the percentage. So we could do that ourselves also, but anyways I admit it's nice to see how Microsoft was created to get some inspiration, but we already understand how it was created. Now let's look back which function in the time intelligence is still interesting and we haven't had a look at. So if we have a look here, we see this also, the rolling average. So now we would like to understand how Power BI is creating the rolling average, because there's a really interesting calculation that we might want to use in our reports, and it also a little bit more complicated, and therefore we would like to have a closer look, because we always want to understand how the measures are created so that we learn and can do that ourselves. So let's start create in this rolling average. Of course, a base value, we again would like to have our revenue as the date column. We of course also want to use the date table with our date, and here we can now select a period. So what is this rolling average doing? It is creating the average of, for example, if we do it like this, the last 10 days. So we just have to say that we want to create the average
and for the average it's always calculated the last 10 days, because we have 10 periods and the period itself its days. We can also say we want to calculate the last 2 months, or we can even say we'd like to calculate the last 2 months and we also want to include the periods that are afterwards. So then we consider the last two and the two periods after the current context. In our case, let's change it back to days and use the last 5 days. So we have here in the period 0 afterwards. So let's have a look how this measure looks like and how it works. So first of all, let's have a look how this looks in our chart. So let's move it here, and we want to only see the ruling average now. And so we see here, this is the ruling average. We can move down to the last period, and then here we see the ruling average. Maybe it's easier to understand if we look at it in our table. So therefore, to understand also, let's move here the revenue in. So if we would like to understand this value here, we would have to take the average of these last 10 values. So now let's have a look at the measure itself and how this measure was created. So again, we have our if statement, which again I think we don't need. So therefore, let's just remove it, and then we have something that looks maybe a bit complicated in the beginning, but actually we already know most of these things. First, let's also remove this hierarchy because we don't need it, and then let's have a look how it works. So first we have here a variable, then we have here this last date function, and this is actually the only function in this formula that we have not seen yet, because apart from it we already know the average, the dates between the date at, and also of course the calculate function. So therefore, to understand what this last date function is doing, let's have a look at this function as well. So let's create a new measure within our key measures table, and we right click and then select new measure, and now let's just call it last date and use the last date function. So what does this function doing? It's just returning the last non-blank date. So this can be anything. For example, if we are in this context, the last date that is not blank could be the 31st of the December. If we are in the context we are have these days, so here for example 10th of January, the last date within this context would be 10th of January because there is only one date. Let's have a look if that is true. So let's select this column here and just create this simple measure. Let's move it first in here. We see here this was always the latest date, 31st of December, except here in 2020 because this was the latest non-blank date that is available within our data. And also we have used it in this context, then we would see that here it would be just exact same date. Let's make that a little bit easier to read, and so let's make it like this, and then we will see here in our dates that these are the first dates that are available in this column, and therefore here this 1st of May is just the same date because this is the only date that is available in this current context. So here also always the context comes into the consideration as well. So now as well as you understand this last date, let's just remove it from here again and just make this again as it has been before,
And now let's have a look at our rolling average works. So first of all, we have here this last date variable that we now understand always returns latest date that is not blank in our current context. And then we have here the AVERAGEX function. And if we think back how the syntax of AVERAGEX function is, and first we need a table and then we need an expression. So our table is just here these dates between. So this is our table that is always created in our AVERAGEX function. So for example, so for each of our contexts, if we have a look again, let's actually change it to the dates itself, a little bit easier to understand. So for each of these rows, so in every context in this AVERAGEX function, there is always a table created. So for example, if we are in this context, there is always a table created, and this table includes the last 10 days of the dates. So to understand that, let's have a look again. Here we see the AVERAGEX function. We use a table, and for every context we create here this table. So that means that here we have the dates between. We use here this date as our column, and then we have always a starting date, which is here the date. So that just means that we go 5 days back in the current context, and then we go to the actual date of our context. So that means in our case that we when we are in the 11th of May, we go 5 days back, and this will be our context in which our average is calculated. So we have these last 5 values that are used to calculate the average. And then we have to also select the expression in our AVERAGEX table, which is just of course the revenue. So basically really it's not that complicated. We just use the AVERAGEX function, and in this AVERAGEX function we have our table for every context we are in, and we always take in this context the last 5 days into our average. So now as we understand it, we can easily change here this measure. We could, for example, just change it to months. We could do any other modification that we want. So we have really now, as we understand how it works, full control over our calculation and over our measure here. So now we have already seen some filters and some time intelligence. Now let's have a look on what does this aggregate per category mean. So here we have some aggregation like average or maximum minimum per category. So let's now get some idea about what that means and how we can use that. So let's select, for example, the average, and as our base value again select our revenue measure. And now here we can select a category by which we want to calculate the average. So for example, we could want to calculate the average by our customer. So therefore let's move the customer in here, click on OK, and then have a look at what this measure is doing. And again we have here the measure in the wrong table, so therefore let's just change the home table to the key measures table, and then let's move the measure in our table to see what the results looks like. So here we already have our customers, and now we would like to see what this measure looks like when we visualize that together with the customers, because we have calculated the average per customer, and we will quickly see that this is not a good combination. So let's move our measure into the table, and now we see something that is a bit surprising, because if we also move the revenue measure here, then we see that this is exactly the same, because Yeah, if you think about what our measure is doing, it's calculating the average per customer in the current context. So in this context of each row here, we have only one customer. So of course, the average of only one customer is the amount of the revenue by this customer itself. So therefore, we have only the same values. So that means if we calculate the average per customer per category, then we should not use this category. So to say the name here, the customer in the same visual, that doesn't make sense. Something that makes a lot more sense. Therefore, let's move it here out of it and then visualize it in something else. So with every category apart from the category itself, so in our case the customer, it makes the sense to use this visual. So for example, we have now visualize it with the years. So now that means that per customer we have here this average in 2017. So now in this context of 2017, let's say there were 100 customers in 2017, then we can calculate the average of that year per customer. Maybe in the context 2018 there are a bit more customer, but then still we can calculate the average per customer in 2018. So in this context, or something else could be, we could calculate the average, for example, per customer in each of the states. So in Arizona, the average was $28, and if we see the total of all the customers everywhere, then this was $214. So just be aware when you use this measure that you want to use it with another category that is not the category by which you calculate the average. So in our case, it was the customer, because that doesn't make sense to use it with the same category as well. So now let's have a quick look to our quick measures again, because I think now the aggregation per category is the same for max, mean, variance, and so on. But we have something that is still left here. So for example, we have here the mathematical operations and also the text. So these are the two kind of interesting things. Let's have a look at here this text quick measure, because these text quick measures, they are really promising. So for example, we have here a star rating that might be really interesting. So therefore let's look at this star rating. So of course we can select again a base value, that is in our case again our revenue measure. So now our star rating would be based on our revenue measures. Here we can say how many stars are the maximum star. In our case, let's just leave it at 5 stars. So here we have the value for the lowest star rating. So that means that if we are lower than this value, for example, we have negative revenue or zero revenue, then there would be 0 stars. So therefore we can, for example, say if we are lower than $100, then we have 0 star rating. And the highest value, this is the value that we are give 5 stars. So when the revenue is higher than, let's say, $500, then we have a 5-star rating. So therefore let's look at what this measure is doing. We created, and now let's move this newly created measure in here, and then just visualize that with a table, and we can also just remove that here, and also this we don't need right now. So let's have a look what this star rating is doing. So right now we have here 5 stars, of course, because we have here this revenue which is in this context higher than $500. But now let's move also the customers in here, And then we have here these star ratings that are ranging from 0 stars up to 5 stars depending on the revenue that this customer has created. So now we are curious on how this measure was created. Therefore, let's have a look at the formula of this measure. So if we look at this measure, we see that it looks in the beginning a bit complicated because we have here 5 variables and then we have here our calculation. But actually our calculation is not so complicated, and also our variables are really easy to understand. So first we have here the number of stars. So here we could also change it to 10 stars or leave it at 5 stars. Here we have just our mean value, our max value, the base value, which our star rating is based on. And then the first calculation step, what we are doing is that we are normalizing the base value. That means our revenue. So this happens here, that this is just a normalized, so every well value will be between 0 and 1. So with this we can now use it within our star rating. So now in every context we have for the revenue a value between 0 and 1. So this is our normalized base value. So for the maximum revenue we have 1, for the lowest revenue we have 0. So now with this normalized value we can multiply that with the star rating, and then of course we should round it to whole numbers, and then we have again here the number of stars. So this can be 5, 4, 3, 2, 1 and 0, and then we are just presenting the stars, so we do this by this repetition function. This repetition function is just repeating the star this many times of the star rating. So if we have 5 star rating, then just this star, which is just this text symbol, only char 9733 is just repeated 5 times, 4 times, 3 times. And then we have here these other stars. This represents the missing stars. So if we have 3 stars, so then we would have 3 real stars, and then here we would have also 2 stars that are missing, so they are presented as well, and we can just combine them with this n%. So before we move in, let's again have a look at this repetition function to really understand here this star rating measure. So if we create a new quick measure, then we can just use this repetition function that repeats a text a given number of times. So we could, for example, just use this text symbol. So we can say this is just 9733, and then we can just repeat that 3 times, and then if we visualize that, we would see that now there are 3 stars because we have repeated our symbol, which is the star, 3 times. So you see, actually this measures is not even that complicated, and now we can even adjust it to our needs. So for example, we could say we want to visualize another symbol and then just have this other symbol, or we can make more stars or make some other adjustments to that fit really what we need in our case. And that's really the great power of DAX, that we can use them and modify them, because it's really important that we have understand the syntax so we can modify them and adjust them to our needs. As a last example of why it's really good to understand what is happening, because otherwise we are a bit lost with these quick measures.
we have a look at our mathematical operations. So for example, let's have a look at this multiplications. I'm sure this is now really easy for you, but it's a good example of why we should understand what is happening. Otherwise we will be a bit lost and we will even wrong calculation. So let's say we want to calculate the revenue. So that means we want to multiply the in the sales table the price with the quantity, and we already see that, of course, we know that there has to be always an aggregation, which is in this case the sum. But if we don't know that, we might think, okay, we have the price multiplied with the quantity, this will be the revenue. Of course we know better, but it might be the case if you don't know about DAX and about measures. So we have here this quantity, and also let's visualize that in a table together with our revenue. So we see already that this is too much, because when we look at the calculation we understand that this is not what is supposed to happen here, because actually we just calculate the whole sum of the price. So we calculate all the products prices, sum them up, and then we multiply that with all the quantity that happens and multiply that with that huge sum of the price. So of course we will get a value that is a way too big. We know that when we want to calculate the revenue, we want to use the SUMX function, because we want to calculate on a row level first the quantity and the sales price in every row of the sales table. So for that, for every transaction with a certain quantity and a certain price, we get the result of that, and then just in the end, after this is calculated for all the rows, we want to calculate the sum. So I hope you understand that you can get the full potential of measures when you really understand the DAX syntax and know what you are doing, because otherwise you will end up getting things that are not what you want, not what you expect, and are just wrong calculations. And now if you understand DAX, you can even use these quick measures and adjust them, modify them so that they fit your needs, and you can get great results with them.
So thank you for watching my tutorial till now. Hope to see you in my future videos. Till then, stay happy. Assalamu alaikum.